Hello everyone, welcome to yours unknown trainer, where learning today secures your job tomorrow. In this video, we are going to discuss about number system conversions. In the last video, we have discussed about introduction to number systems, where we have discussed with types also. This video is all about binary to other number system conversion, and next video is all about octal to other number system conversion. So please do like, share and subscribe to our channel. If you have any doubts, leave a comment in comment section. Without any delay, let's start this video. First, I will give a brief about today's topic. If we want to convert from binary to octal, then we have to use 3 bits of binary, and from binary to decimal, then we have to multiply with power 2, and for binary to hexadecimal we have to take 4 bits per digit. First, we are going to discuss about binary to octal conversion. Take a binary number. I am taking 1011011 and convert this number to octal number. We need to represent with binary base 2 and for octal base 8 like this. As I said earlier, for binary to octal, take 3 bits for each digit. We have to choose the numbers in this direction. This 0, 1, 1 as one digit, 0, 1, 1 as another digit, and only 1 left, so 1. So we need to take 3 bits. So to match 3 bits, we have to add zeros. If we add zeros on left hand side, it doesn't change any value because it is MSB. If we have add zeros on right hand side, it is LSB, so the value will be changed. To know the values of these numbers, we want to know 4 to 1 code. The 4 to 1 code is like this. For 0, it is all zeros. For 1, it is 0, 0, 1. For 2, 0, 1, 0. For 3, 0, 1, 1. And for 4, 1, 0, 0. For 5, 1, 0, 1. For 6, 1, 1, 0. And for 7, 1, 1, 1. In this way we'll cover all the octal numbers from 0 to 7. From the 4 to 1 code, 0, 1, 1 is nothing but 3. Here 0, 1, 1 is 3 and 0, 0, 1 is 1. So in octal, the value for 10110111 is 133 base 8. That is 101111 gives 133 base 8. This is example 1. This is one type of question. And now example 2. Let us take another binary number 1011.01011. Convert this binary number into octal number. If the question is given in dot form like this, then we have to go left side of arrow like this and right side of arrow like this. We have to add 3 bits to make one digit. Let us take decimal point, take this point, take 3 bits 0, 1, 0 on right hand side and 1, 1, 0. By keeping the 0, the value is not changed, and in left hand side 1, 1, 0 for one digit and left with 1. Adding 2 more bits will equal a digit. 110 is 6, 010 is 2, 011 is 3, and 001 is 1. Then 1011.01011 base 2 in octal form is 13.26 base 8. Till now we have discussed binary to octal conversion. Now we'll move into second method, that is binary to decimal conversion. For that, multiply each digit with 2. Let us take a number 1011 base 2. Convert this number into base 10. Base 10 is decimal conversion. As we discussed earlier, we need to multiply this radix 2 to each bit of binary, that is also from this left side. So 1 into 2 power 0, we have to start with 2 power 0 and go further. 1 into 2 power 1 plus 0 into 2 power 2 plus 1 into 2 power 3. 2 power 3 is 8 into 1 plus 0 into 2 power 2 is 4. 0 into 4 plus 1 into 2 power 1 is 2 plus 1 into 2 power 0 is 1. That is 8 plus 0 plus 2 plus 1 equal to 11. 1011 in binary is equal to 11 in decimal. Let us take another example for easy understanding purpose. Let us take 0110.110. Convert this binary number into decimal number. We have to multiply 2 with powers as positive sign from this side and from powers as negative side to this side. That is, take a point, decimal point like this, and for right hand side 1 into 2 power. Here we are starting with 2 power 0, so below 0 we have values like -1, -2, -3, -4. So we have to multiply with negative values. 2 power -1 plus 1 into 2 power -2 plus 0 into something is 0. And from this side 1 into 2 power 0 plus 0 into something 0 plus 1 into 2 power 2 plus 1 into 2 power 3 is 0. And 2 power 3 value is 8, 2 power 2 is 4, and 2 power 0 is 1. 1 into 1 gives 1 point. 2 power -1 is 1 by 2. 2 power -2 is 1 by 4. That is 8 plus 4, 12, 12 plus 1, 13 point. You can return this 1 by 2 as 0.5 and 1 by 4 as 0.25. By adding this we get 13.75. Therefore 01101.110 base 2 is equal to 13.75 in decimal. Till now we have discussed about binary to decimal conversion. Now we are moving towards binary to hexadecimal conversion. As we discussed earlier, for hexadecimal we need 4 bits to make one digit. So Like Octal, we have 4 to 1 code. In hexadecimal, we have 84 to 1 code. That is same as like Octal. Keep 84 to 1, and for 1 we have 0001, for 2 0010, for 3 0011, and for 4 0100, for 5 0101, and for 6 we have 0110, for 7 we have 0111, for 8 1000, for 9 1001, for 10 1010, for 11 1011, and for 12 1100, for 13 1101, for 14 110, and last for 15 we have all ones. For hexadecimal, we will count the values from 0 to 15. We know that 0 is always 0. Let us take an example. 101111 base 2 to convert it base 16. In this also we have to move in this direction because we don't have any decimal point here. So take 4 bits to make each digit. From this side 4 bits is up to here, that is 1011, and we have another 3 bits here, 101, and 1 bit is missing, so we need to add 0. The value for 1011 in here is 11, so it is 11, and 0101 is 5, so keep it 5. In introduction to number systems, we have already discussed in hexadecimal we don't have the numbers like 10, 11, 12, 13, 14 and 15. Instead of that we use A, B, C, D and E, F. For 11 we use B, so it is 5B. Therefore 101111 in binary is equal to 5B in hexadecimal. Let us take another example too, that is 1101010.1111. Convert this binary number into hexadecimal number. We have to mark this and mark this side. Take this point as middle and take 4 bits 0101, 1011. See 0101 4 bits, 1011 4 bits, and this side 4 bits 1111. The value for this is 15, but we don't want to write 15. 15 means F. For this it is 10, we need to write A. For this it is 13, that is D. Therefore 110 10.1111 base 2 is equal to DA point F in hexadecimal. That's all for this video. If you have learned anything new, please like the video and leave a comment. I have learned the binary to other number system conversion successfully. In the next video, we are going to discuss about octal to other number system conversion. Thank you.